Thank you everyone for joining us for this webinar entitled The Match and Merge Story, Improving Search Results, Reducing User Confusion. I am Tyler Hauk. I am a Senior Metadata Librarian with Libris. I've been in that position for about 6 years, in which time I've worked chiefly on the Summon Discovery product. I also received my Master's of Library and Information Science from the University of Washington in 2009. And this webinar is about the match and merge story, if you will. But really, the match and merge story starts with the story of discovery. As I'm sure you're aware, discovery services play a very important role in research in the library market today. These discovery services must provide extensive resource coverage. They must expose the best of those resources. They must connect users to the most relevant of those resources, and they must ensure that that access is reliable. With universities and similar institutions competing for students and researchers, they need ways to stand out and excel, and the discovery services they offer can be a part of that. As I'm sure you're also aware, metadata plays a critically important role in discovery as it drives discovery outcomes. Discovery benefits most from metadata that is of the highest quality, the most detailed, and the most expensive. Our philosophy with regards to these principles is that we want to pull from the largest available pool of metadata in order to have the best possible metadata inputs to drive discovery and thus produce better outcomes for discovery users. This stands in contrast to, for example, restricting the discovery process to using only a narrower range of metadata rather than all available. To help us achieve these discovery goals in the marketplace, we created the Central Discovery Index, or CDI. This is a unified discovery index. That is an index where all the records are stored in the same index using the same metadata schema. This would be in contrast to, for example, a federated search model, which queries different indexes using different metadata schemas. Content in the CDI comes from a variety of sources, including publishers, content aggregators, such as ProQuest and Gale, open access websites, institutional repositories, and many more, including our own clients in some cases. Content in the CDI represents numerous different material types, although it is chiefly oriented towards scholarly content. And the CDI currently contains approximately 3.6 billion individual records, which in this context we refer to as physical records. This content is processed by the Libris Content Operations team. This team manages the automated processes used to retrieve the content. They ensure that the retrieved records are correctly processed into records that conform to the CDI metadata schema. And they maintain and edit the metadata as required. The Summon Discovery product will start using CDI by the end of November 2019. Note that match and merge behavior in Summon will remain unchanged after this transition. Primo, on the other hand, will start using CDI in early 2020. Just to give a brief high-level overview of the content ingestion process, the process managed by the Libris Content Operations team that I just mentioned. This process starts with the identification of a new source of content for the index. We then evaluate a sample of that content, and once we have approved it, we enter into an agreement with the content provider. After that, we're able to acquire a full set of the source metadata for that content, which we then prepare for ingestion into the CDI, doing things like standardizing the metadata, organizing the field mappings, configuring the linking scenarios, and so forth. The content is then deduplicated at the point of indexing. Some elements of match and merge happen at this stage. and afterwards the content is maintained as needed by the content operations team. Once this content is actually in CDI, the discovery layers that use CDI can surface it as search results. These search results are delivered to the discovery layers in real time, and they are based on the user's query, their subscriptions, and whatever customizations may have been made to the discovery layer that they are using. Things like search relevancy and some aspects of match and merge happen live at this stage. This also means that records from the index are not just surfaced simply as they are. Different users may see different results for the same basic query, again, depending on the details of their subscriptions and the customizations of their discovery layer. Now, what exactly is match and merge? Simply put, it's a system for improving the search results retrieved from the CDI. And it does this by performing three primary functions: the deduplication of citations, the optimization of metadata, and the optimization of access. With regards to the deduplication of citations, we get content from a wide variety of sources, and therefore, oftentimes, we have more than one record for a given citation. In some cases, we can have as many as dozens even. Displaying all of these records separately could confuse users and potentially make it harder for them to find what they are looking for in their search results. So we want to display all the records we have for a given citation together as a single search result. With regards to the optimization of metadata, the quality and completeness of metadata may vary between different records for the same citation. Thus, by combining these records, we can take the best metadata from each of the records and present the user with the overall highest quality, most complete metadata we have available for that citation. With regards to the optimization of access, Match and Merge also allows us to provide the user with the best and most reliable link to the content for any given citation. Without the benefits that Match and Merge provides, search results would be more difficult to navigate and of a lower quality, and the access we could provide would be less reliable. So Match and Merge helps us achieve our goals for discovery by making the search results cleaner and less confusing for users. Also, note that my understanding is that some discovery products do not have similar features. I believe that EBSCO EDS, for example, surfaces their records as they are without some of the optimization processes just mentioned here. Now, how does Match and Merge actually work? Match and Merge is, as I mentioned before, a system. It's a process. It's a series of criteria governing which physical records can be combined or merged, as we say, into a logical record and under what conditions. You can conceive it as a process whose input is the physical records in the index and whose output is these combined or logical records. You can think of these logical records as master or super records, if you will, in the sense that they allow the user to have the best of all worlds. Since all of the available metadata is synthesized to form the logical record, we can surface the best of all available metadata optimized for the user's experience. Logical records, by definition, consist of two or more physical records, which in the context of a logical record are referred to as participant records. And we call these logical records because they are created based on a series of rules, which is to say logic. But there's another meaning you could infer, and that is that it's common sense to do so. It is logical to use all the resources we have available to the maximum effect. That is our philosophy. This differentiates from grouped or best available record approaches, which some other discovery products use. For example, Primo uses an approach like this presently. This may deduplicate the records for a given citation by grouping them together, but it does not combine or synthesize the metadata into new records. like we do with logical records in the match and merge process. I'm going to walk through a practical example of the compilation of a logical record. I'm not displaying an actual record as it appears in the index, but this is a real citation. The title is Cancer, the RAS Renaissance by Heidi Ledford. It appeared in the journal Nature in April of 2015. In this example, we have a number of different records for this citation, one of which has a DOI, another has start and end page values, a third has some subject headings, a fourth has an abstract. When the logical record is compiled, we can take these metadata points from each of the merged records and thus producing a logical record that has the DOI, the start and end pages, the subject headings, the abstract, and any other available metadata points all combined together in the same logical record. This is not just a grouping of the participant records. A logical record is actually a new record made from the metadata of the participant records. As I mentioned earlier, match and merge is a system of rules, of criteria, and some of these include rules that govern which records can merge and under which circumstances. One of the more common scenarios would be matching external identifiers. For example, if the record's DOI or PMID, that is PubMed ID number, match, the records can merge, provided that they satisfy several other criteria, such as their titles match. We can merge records based on matching ISBNs and EISBNs as well, again, provided that their titles match and that they are published within 1 year of each other. We can also merge records based on matching ISSN or EISSN, provided that their place of publication or date of publication match. And we can also merge records based on the LCCN, Library of Congress Control Number, or OCLC number, again, provided there's a matching title and provided that the place of publication or the date of publication match. Another common match and merge scenario is one based on an internal publication level identifier that we maintain through our authority data. One such scenario is merging at the publication level, which is to say records of the type newspaper, magazine, journal, book, etc. If the internal title level identifier of these records matches and their titles match, they can be merged. Similarly, we can merge at the article level based on the title level identifier. So this would affect records of the type journal article, magazine article, newspaper article, and so forth. In this case, the publication level identifiers have to match also the title, year of publication, volume, issue, and start page. This is the most common match and merge scenario currently employed in CDI. We also employ several other match and merge scenarios, such as reference records are allowed to merge if they simply have matching titles and are published within 1 year of each other. Dissertations can also merge if they have the same URI, or that is to say, link to the content. The assumption there being that if two dissertations are accessed at the same location, they are likely the same item. We also employ the inverse of these rules, which we call filters. The match and merge rules specify when records can be merged. The match and merge filters, on the other hand, specify when records cannot be merged. One of the more common scenarios for match and merge filters is mismatched metadata. For example, if records have different DOIs or different PMIDs, the records are blocked from merging. Records also cannot merge if they have the same URI, provided that the records are from the same content provider, and were acquired together as part of the same grouping of records. Records also can't not merge if their languages are different. And note that that can be affected either by the language identified in the record's metadata or the language of the record metadata as detected by our system. For example, if we have a record whose metadata is in Spanish, but the record is identified as being in English, our system can intelligently determine that the record is in fact a Spanish language record. We have a number of other filters that we employ for match and merge as well. For example, records identified as being from institutional repositories will never merge with any other record. We can also set a value we call the record exclusion flag that simply exempts the record from the match and merge process. We usually have to set this in response to a specific request from a content provider who does not want their records to match and merge with other records for whatever reason. And finally, we also have a list we maintain we call the bad titles list. This is just a list of very simple, very generic titles that we don't want to allow to merge. And also, similarly, we employ a filter we call the overmatch filter, which stipulates that any title that occurs on more than 4,000 unique records in the index will not be merged. The idea in both the bad titles and overmatch scenarios is that we don't want records merging which should not be merging, and by blocking records with very simple generic titles from doing so, we believe we can reduce the incidence of that. I want to just mention a brief word about a principle we call transitive merge. In the abstract scenario we're displaying here, record A can merge with record B. Record B can merge with record C. Records A and C could not merge together on their own. However, based on their commonalities with record B, all three of these records can be merged together into the same logical record, and when this occurs, we call it a transitive merge. This is particularly important for us because it allows us to leverage more broadly metadata from what we refer to as enrichment records. Enrichment records usually include supplemental metadata such as the full text of an article, which can be used to improve search relevancy. It can also include things like citation counts from organizations like Scopus or Web of Science. And these enrichment records are typically merged only with their parent, if you will, a metadata record. However, when that metadata record can merge with other records for the same citation, we can then leverage and surface the metadata from the enrichment records more broadly than we otherwise could. Also, a brief word about user-uploaded content. Users of both Summon and Primo can upload their content for use in those discovery layers. However, note that Summon data uploaded by users is intermingled with other data in the CDI. Primo, on the other hand, stores its user-uploaded data in a separate index that is queried separately only by Primo and is not intermingled with records in the CDI. As such, records uploaded by Summon users will match and merge with other records in CDI by default. That is subject to certain settings. Clients can opt out of this. They can prevent their records from matching and merging with other records. Primo users, on the other hand, their records they upload will never match and merge with other records in the CDI. One of the results of the match and merge process is the display that the user sees. You'll notice that this slide does resemble the slide I showed earlier about the compilation of a logical record. However, note that in this case, what we are looking at is which metadata elements from the already compiled logical record are selected for display in response to a user's search. The metadata is surfaced from all the available records, meaning those returned by the query. What this does is it gives the user the most complete metadata for the citation that we have available for them, since it takes into account their subscriptions and customizations, etc. Participant records that the user does not have access to will not surface for display, even if these records are included in the logical record returned in the search. This this process uses the logical record if available. If one is not available, it uses the physical record. And note that all the available metadata fields are surfaced. However, if there are multiple possible values for a given data field, only one version is selected for display, and that's based on a predefined hierarchy of record types. For example, if there are two records in the logical record that have the same author value, but they capitalize this author's name slightly differently, only one of those values will be displayed rather than both. Also, please note that in Summon in particular, all faceted metadata values, such as subject terms, languages, content types, and so forth, from all participant records are always displayed, irrespective of the user's subscriptions. This is not the case with the metadata displayed for the citation. It only applies to the faceted metadata. Another result of the match and merge process is the method of access. When a user clicks a matched and merge search result in either Summon or Primo, the API selects what it determines to be the most reliable link available based on the user's rights, which is to say subscriptions, and the available record metadata. By most reliable link, what we mean is that the API prefers to use a URL directly from a record or a URL that can be derived from the record's metadata. If such a link is not available, or if the user's subscriptions do not indicate access to such a link, then an open URL query is sent to the user's link resolver. There are some exceptions to this process, and users can sometimes request some small customizations to their linking behavior, but this is by and large the most common scenario for linking used in CDI. There are some minor differences between Summon and Primo. For example, Summon displays separate links for catalog records. Primo forces linking through SFX and ALMA for certain resources, but overall the behavior between the two products, both using CDI, will be largely the same. Now, match and merge presents us with a number of significant challenges. As I've alluded to, match and merge is a system, and perfection is difficult to achieve in any system. We encounter a number of issues related to this, and we do our best to resolve them and mitigate them. With respect to the balance, loosening restrictions on match and merge rules and filters would cause more records to merge than would presently, and that might increase the number of erroneous merges. On the other hand, tightening those same rules and filters could lead to increased duplication of records. So much of match and merge is about striking an appropriate balance between these concerns and trying to give the user the best possible experience. There are also some issues related to the transitive merge principle I mentioned earlier. Sometimes transitive merges can cause undesired results. For example, if one record has ISBNs for both the first and second editions of a book, transitive merge can cause records from both editions of this book to all merge together into one logical record that has metadata that is a mix of both the first edition and second edition, which can be confusing to users. Regarding granularity of indexing, a classic example of this is where one content provider indexes the letters to the editor as a single unit of content under the title Letters to the Editor, and another content provider might index each individual letter to the editor as its own unit of content with its own title. Match and Merge has no way of recognizing that these records are actually for the same content and thus cannot merge them. We also have to deal with some exceptions at times. As I mentioned earlier, sometimes content providers explicitly request that we not match and merge their records. This can lead to duplication that cannot necessarily be remedied, but we have to honor the requests of these content providers. And lastly, as I'm sure you're aware, with an index of 3.6 billion records, some metadata errors are inevitable. We try to edit and correct these as we are able, but they can cause match and merge failures in many cases because match and merge interprets these small errors and small discrepancies between the records as legitimate differences rather than simply errors or typos. We try to address these issues, these challenges, as best we are able to. Since match and merge is a system, it is evolving, we can make changes, and periodically we can reevaluate and adjust the rules and filters that make up the match and merge system. As I mentioned, our content operations team also is able to correct metadata errors. However, some problems cannot be fixed. For example, the granularity of indexing problem I just mentioned. That is beyond the scope of match and merge to address. It's worth it to us, though, to keep working on match and merge and keep improving it because ultimately everyone benefits from match and merge. Users get better search results. Librarians can render services more effectively to their users. Content providers get their metadata represented in a fair and unbiased manner and are offered an equal opportunity to be linked to. It's also important because it helps us comply with the terms of the Open Discovery Initiative, or ODI. And that's important to us because we want to foster collaboration with both our customers and the rest of our industry. To that end, we have the Content Working Group, which is a part of Igloo and Eluna. This is essentially an advisory board, the goal of which is to ensure high-quality data in our knowledge bases and indexes. We also have the ALMA Community Zone Management Group. This is a subgroup of the ALMA Working Group, which focuses on community zone content. It is also a part of Igloo and Eluna. And we have the Ex Libris ID Exchange, which is how we field suggestions and feedback from our customers. At the industry level, several of our employees are sitting on several NISO committees, including the Discovery and Interchange Topic Committee, the NISO KBART Standing Committee, and the KBART Automation Committee. We participate in the Library of Congress's program for cooperative cataloging, and we are actually the only commercial entity currently taking part in that program's Cataloging in Publication Partnership Program, which is formerly the Electronic Cataloging and Publication Partnership Program. We also participate in 2 of Metadata 2020's projects, those being the Incentives for Improving Metadata Quality project and the Research Communications project. And lastly, we have the Ex Libris Provider Zone. This is an initiative in ALMA which allows content providers to ingest their own metadata directly into the ALMA Community Zone. I'd like to thank you all for joining us.